All right, so 5.3 review. We're talking about solving quadratic equations, so I'm going to do a few examples. Also going to talk about restrictions on variables and how that works. So let's take a look at one from 18. This is from your review assignment. Let's take a look at 18b. So it says root 4 minus x, all underneath the root sign, equals negative 2. So it says identify values for x for which the radicals are defined. What that wording means is that what are all the possible values for x that are allowed in this question. So we know that x can be anything, but it can't be any values that cause this to be negative, right? We cannot have a negative under the root sign. So as we've done, you take this little piece out, 4 minus x, and you go over out of the side here, and you say this has to be greater than or equal to 0. It can be 0. Square root of 0 is 0. But it can't be negative. So if this has to be greater than or equal to 0, then this is what you do. Okay, well, let's subtract 4 from both sides to get x by itself. Well, we're close to having x by itself now. It's negative. That's no good. So what we have to do is we have to divide by negative 1. When we divide an inequality by a negative, do you remember the rule we have to do? We have to what? We have to flip the inequality sign. Very good. That's just the way it works. And I can show you why later, but I won't bother. If you divide or multiply by a negative, you have to flip around the sign. See how it was greater than or equal to? Now it's less than or equal to. And then this becomes a positive 4. Okay? So this is the restriction, or that's the values for x that will cause this to have a real answer, or to be defined as it says here. Now it says solve for x. So what we're going to do is I've got a radical, a square root that's isolated on one side. That's what you want. And what you can do in an equation is do the same thing to both sides, which includes squaring. You can square both sides. So I'm going to square this. When you square a square root, they like cancels each other out. So this simply becomes 4 minus x, because this is gone with the root sign. Okay, 4 minus x on this side. That's what happens when you square that root. Over here, negative 2 squared is not negative 4. It's positive 4. Okay? So let's see, what can we do here? Well, if I'm isolating for x, I could either take x to the other side and make it positive. So let's try that. Add x to both sides. And then I could subtract 4 from both sides to get rid of it over here. So I have x equals 0. X equals 0. Okay. So x equals 0. This is what I get algebraically. What you want to do is one of two things. If you've done this, first of all, you can check your answer with all of the allowable values for x. X has to be what? Less than or equal to 4, is that correct? So it cannot be greater than 4. Okay. So 0 looks to be in that category, right? What's the other thing that you should always do, though? The other thing that you should always do is what? Check. Okay, so let's check. What happens here? Square root of 4 minus 0 equals negative 2. The square root of 4 equals negative 2. If we take the square root of 4, that should be 2. Can it be negative 2, though? Yeah. Okay, so we usually do a plus or minus 2 here. Is that correct? Okay, so here's the thing. When we take a square root of a negative number in the question as an operation, then we usually have to allow for a positive or negative answer. If the question starts off with a negative like this, if it starts off with a radical like this, usually they're only looking for the positive outcome. Okay, so I'm just going to direct you right here to the solution manual here. If you look at this here, when we're checking like this, if you have a radical that's already in the question, that root would always be the positive root. So if you have a radical in a question that equals a negative, you have a bit of a problem. So this is a tricky one in that the square root of a number, if that root sign, that radical is already in the equation, the answer to that would be a positive root only. Okay? So again, if we're taking the square root of a number, we often have to allow for the positive or negative value. But if it's already kind of stationed in a question, then the positive square root is what we're actually looking for. And here's the thing. If this was a positive 2 and we squared it, we would still get 4, right? But because it's a negative 2 and we squared it, it still is a positive 4. So how do you account for this negative, right? Do we, you know what I mean? Like, so there's some shortfalls when it comes to solving algebraically. So when you plug your value in, the square root will always yield the positive answer. So this one, there's no solution because the left side and the right side technically don't add up. The other thing that I might show you here is, if we graphed this, the intersection point would represent the solution, right? The two graphs. So let's see what happens. So yeah, if we were to graph these, you see that there's no intersection point. So there's actually no solution. If y was positive 2, then there's a solution. You see that? Then x would be equal to 0 if it was positive 2. But because it's negative 2, that's why we say, you know what? A square root in the question cannot equal a negative value. Because if you graph it, there's no intersection, there's no solution. So a few things you got to check. That one's a bit of a tricky one. All right. Let's do something from 19 that doesn't have this sort of trickiness in it, I don't think. Let's just pick one. But one that has radicals in 2 spots. Okay. How about this one? This one looks like one of the trickiest ones there. Okay. So root 8 minus m over 3 equals root 3m, and then minus 4 is outside the radical. All right. So with this one with 2 square roots, what you need to do is isolate one square root at a time. So here we have the radical all by itself on one side, so that's good. What we need to do now is we need to square both sides to get rid of this radical over here. So this over here, again, squaring a square root cancels that off, so we just write out whatever's underneath there, 8 minus m over 3. Now over here, please don't do this. Please, don't write this down if you're writing this down, but please don't do this. I'm going to square everything over here like this. Okay, that's very tempting, and I've seen many of you do that, and over the years, students always do this, but please, you cannot do this. If it's a subtraction or an addition that's a binomial, what you have to do is you have to square the binomial. So it's like this right here. The whole thing is squared. You see that? The whole thing. So you have to do the FOIL method. So you have to treat it like this. Like you have root 3m, minus 1 multiplied by itself.
It's minus 4.
Oh, 4, sorry. Where'd that 1 come from, eh? Maybe I accidentally erased it. So I have, over here I have 8 minus m over 3 equals root 3m times root 3m is just 3m. And then I have minus 4 root 3m minus another 4 root 3m. So that's minus 8 root 3m, right? And then I have plus 16. Everyone see that? So you got to FOIL that out. This is going to be a little bit of a longer one, all right, because I have another radical in here I got to get rid of because the m is trapped underneath there. So let's get everything over to one side. I'm going to subtract 16 from both sides. I'm going to subtract 3m from both sides. So 8 minus 16 is negative 8. This is still minus m over 3 minus 3m equals negative 8 root 3m. Okay. Now you can combine some of these things, right? These terms are actually like terms right here, because that's like 1/3 m minus 3m. 1/3 minus 3. They're both m terms. Okay. So what does that turn out to be? 1/3 minus 3 is negative 2 2/3 or over 3. So this 3 is actually 9 over 3. So negative 1 minus 9 is negative 10 over 3 m. Okay. So again, gather like terms. Make sure you do your addition subtraction properly. Okay. So let's see. Where do we go next? Well, I'd like to get rid of this 3, actually. I'd like to get rid of that 3. That would be really nice. So what you could do is you could multiply everything by 3. So 3 times this term will be negative 24. 3 times this. The 3's are going to cancel out there. So that's just going to be minus 10m. 3 times negative 8 is going to be negative 24 root 3m. So now I've gotten rid of the denominator there in that one term. So I'm pretty close here. You don't have to divide by 24 to get rid of this. You can just square this whole term, and you'd have to square this as well. And so this is a long one, but again, we're going to be getting rid of this radical now. And so we're getting closer. So 24 squared, you may know that, but let's calculate that here. So negative 24 times negative 24 is positive 576. Root 3m times root 3m, guys, is just 3m, right? So this is what we have over here. This one over here, again, it's a binomial, 2 separate terms. You're going to have to expand that out. So we have to square this whole thing. So 24 times 24 is 576. When we do the expansion there, you're going to have negative 240, or sorry, positive 240m and another positive 240m. Plus 100m squared. Okay? And this over here, 576 times 3. So let's rearrange everything here. So we got 100 m squared plus 480m plus 576. And then this over here I'll bring to that same side as well and go minus. This is taking forever, yeah. 576 times 3. But the fact that it's taking forever, it's just a long journey. It's not a journey that's impossible. It's just a bit of a longer journey. So guys, listen, this is why you have to focus, okay? We have to focus for 10 minutes on a question sometimes. So when you're working in class and you're telling stories while you're working or whatever, like I see some of you doing, you know, it's to do this well, you have to focus on one thing. Like I'm trying to focus on you guys while I'm doing this. But if you focus on one thing and can block things out, this will go much smoother for you, right? Okay, so it's a longer question, and like I say, I'm stopping and all this time too. But if you guys are distracted, it's going to make this seem impossible, which it's actually not. But now I don't know where I am. Okay, 1728. Okay, 1728m equals 0. Okay, so if you guys notice, we're getting close to a quadratic here, right? What's 480 minus 1728? So 480 minus 1728, because these are the m terms. Minus, what was it? 1248 m plus 576 equals 0. So these are big numbers. This has been 7 or 8 minutes already, whatever it's been. Yep. Did I miss something? Or you have a question?
Question? Like,
yeah.
I think it's easier if we pass the minus 40.
So when you get to this stage, class, sorry, just attention again here. Just finish this off. When you get to this stage right here, and you have a quadratic, you can use a quadratic formula, like we mentioned, or you can graph it and find the intercepts. So I graphed it. It looks like I have 12 for an intercept here, and I have 0.48. So you might want to check those just to see if any of those are reasonable. If you have, okay, so 12, if 12 goes in here, that's going to be looking like it's going to be okay. 12 over 3 is 4. 8 minus 4 is 4. Root 4. 3 times 12 is 36. Root that is 6 minus 4 is 2. So they both equal 2. Not sure about the 0.48. You can maybe check that one out as well. But you want to check both of your solutions. Okay, any questions?